Hi, my name is Krista Gallegos, and today I'll be presenting my development stage of my final presentation. So first is a part list. For the parts I used was an Arduino Uno, a DS18B20 temperature sensor, an LED light, a 220 resistor, a 5.1K resistor, a passive buzzer, a breadboard, a 9V battery and clip, and a USB cable. Some materials and tools that I needed were the silicone curling iron holder, electrical tape, scissors, and silicone suction cup hooks. For the first part was wiring. For my wiring, I had to use multiple jumper wires and multiple pins on the Arduino board and the G&D, also the 5V ports. So the first part, I had to connect the Arduino to the power and the ground wire with jumper wires. Then I attached the power module to the breadboard and powered it with an external source. Next, I distributed the power and ground across the breadboard using the jumper wires. With this, there was two sides on the breadboard. One was a blue side and a red side. So I used the red side as the 5V and the blue as the ground. Next, I placed the LED on the breadboard. I first started off with placing two jumper wires that went off from the anode and cathode, which the longer leg is the anode and the shorter leg is a cathode. So I needed to connect jumper wires onto the pins of the breadboard, as well as give it power through the ground rail. So I connected the longer leg to the resistor and a shorter leg to the ground rail, and then I used jumper wires to connect those. Then I placed the resistor on the long leg row, and then after that I needed to connect the buzzer. I placed the buzzer on the breadboard. I connected the positive leg of the buzzer to the digital pin on the Arduino, which was D9. Then I connected the negative leg of the buzzer to the ground rail on the breadboard using a jumper wire. Then I connected jumper wires for the temperature sensor. Red was used for the 5V, blue was used for the G&D, and white was used for the D2 pin. I connected all these on separate rows. Then I used the jumper wires to connect it to those ports. Then I connected the temperature sensor with each wire in the matching row of the jumper wire. So again, they also had like different colors. It was black, red, and yellow. I used the red as the 5V, just like I said, and I used, instead of black, I used a blue jumper wire, and a yellow was white. Part B, I had to start on the main body. This was the silicone heat-resistant mat before all the alterations I made. Using scissors, I cut off the string that closes the bag. I did this in order to remove that string so that I could have the little hole to use the LED light to place it inside. Then I connected the LED light inside the small hole on top of the silicone bag using jumper wires, and I connected the LED to the breadboard to make it longer. I connected the jumper wires to the breadboard and tested to see if it worked through coding. That was my final prototype. And my conclusion, overall my prototype helped improve the design of the silicone holster by adding LED lights, temperature sensors, and buzzers. By adding these components, I was able to enhance the performance of this holster by allowing the LED light to turn on as the temperature reached up to 350 degrees. Right after it hit 350 degrees, there was a timer set for the buzzer. After 30 minutes of the LED still on, it would send a buzzing sound out that would allow the user to know that they left this tool unattended or plugged in. With this, I was able to help improve the amount of times people left their tools unattended, and this would help reduce the amount of children trying to touch these tools. With using the holster and the hooks, I connected this to my mirror, which allowed for it to gain more height, which a child would not be able to reach. And by putting that height, the child was not able to reach it, as I said, and they also weren't able to reach their hands, since the average height of a 10-year-old would be still shorter than the height I put it on my mirror. When I tested my object, I was able to secure the silicone suction cup holders to the back of my design that was able to suction onto my bathroom mirror. And some inbuilt refinements that I had to make was that the suction cup holders were not holding as well, so I had to use command strips and place hooks onto the command strip and place it onto my mirror. I also was trying to set the LED light on the front pouch, on the front side. Instead, I found it easier to use the little hole that I cut the string off, and that helped my prototype be more visible, the LED be more visible. That is it. Thank you.